Alright, so today we're on the lesson 5. The topic is solving exponential equations with technology. So what's the goal? You're able to identify when common base cannot be used, and you need to solve this exponential using the appropriate technology. So basically, what we are doing is continuing what we did yesterday, except we're addressing this problem right here. Because guess what? In life, not everything works out to be a common base. So, how do we deal with it? So 3 to the exponent x equals 5. We have right now we have two tools in the toolbox here. We can make sure everything's in the same base. We know 5 cannot go in the same base. Second one is to divide to get rid of the 5, but we can't divide by the 5 because the 3 to the exponent x, it's already isolated. Now that exponent 3 to the x is already isolated, so dividing by 5 just makes it uglier. So once we identify that we can't find a common base, we're going to use or apply the graphing calculator. So, using the graphing calculator, here are our steps. And so, I can put that underneath here. Steps. Step 1. We're going to break this equation into 2 separate equations. So break equation into 2 equations. So what's that look like? It looks like this. The first equation will be y equals 3 to the exponent x. The second equation will be y equals 5. And that's what you're going to input into the calculator. So, kind of wrote that, I'm going to have to write that twice because input both equations into graphing calculator. Into graphing calculator. Number 3 is going to be adjust window, and I'm going to show you how. Adjust window on calculator. Now, when I go through and show you that process, you may want to make extra notes and decide as to what you need in order to remember that. So after you adjust window on calculator, you're going to graph it. And then the last thing, you're going to find the point of intersection. So we're just finding point of intersection. So it's like grade 10 when you're finding where 2 lines cross. It's exactly what we're doing here. Okay? Because when do y equals 3 to the x and y equals 5 have the same value, it's where they intersect. Where they intersect. So we're looking for that point where they cross. Okay, so we're looking for, basically we're creating a system of equations and we're determining where in fact do they intersect or where do they cross. So, already got that taken care of. So that slide you can use for examples. Sorry about that. Here we go. So 3x equals 90. So I know that I can't express 90 as a base of 3. So I pull my calculator out. Excuse me. And step 1 on the graphing calculator. If I can turn it on. There we go. I know that the first equation will be 3 to the x. My second equation is going to be 90. So there are the 2 equations. Y1 is 3 to the x. Y2 is the 90. So I'll just put a couple things in here. Y1 will be 3 to the x. Y2 is going to equal 90. Next, I said you had to change the window. So window is the button. I can draw on the calculator here. Here's the window button. So we're going to hit on the window button. Oh. And the window tells me what size, what are we looking at in terms of a window. So for example, x min, the x-axis goes from -10 to 10. Well, how far do I think it's going to go out? At this point in time, I'm not sure. I'm not sure how far I have to go in the x. I'm going to leave in. But what about my y values? I know that y2 is equal to 90. So I know the y value, the max, has to go to at least 90. So I'm going to put it at 100. I'm going to pick a number a little bit bigger. I'm going to graph it because I want to see the intersection point on the graph. So if we go ahead and hit graph, there's the 3 to the x function, and there's the y equals 90. So I can see the point of intersection. So that's a good thing. So there's the point of intersection. That's what I want to know right there. Okay. So how do you do that? Next step, you need to hit second. So we're going to hit the second button. That's your first step. And you're going to hit the trace button as your second step because it allows you to get into the calculator options. So I'm going to hit second trace. So what we're looking for is number 5. We're looking for intersection. Okay, we're looking for the intersection. So to intersect, hit enter. It asks you at the bottom here, what graph or what line are you using here? We only have 2 graphs graphed, so the answer to both questions is going to be yes. So in order to answer yes, you hit enter. You hit enter again because now it's asking, is this the second line? Yes. And it's always guessing because the calculator is actually using an approximation process. And there we go. There's the answer. Okay, right there. Point of intersection occurs at 4.1 and 90. So going back to ours, point of intersection, POI, is equal to 4.1 and 90. So comma 90. Okay. So the answer then, so therefore, x equals 4.1. So you just want the x value. The y value should be whatever was on the left side of the equation. Okay. So there you go. So the tricky part here is just getting comfortable with the calculator, and you're going to actually be using the calculator quite a bit this semester, so it's a good idea to get comfortable with it now. All right, so second example here. Move the calculator over here. What I would recommend is getting in the habit of resetting it for this particular section, and you do that by hitting second function plus 712. All right, so to reset, put it up here. To reset, you would hit second plus, then you hit the number sequence 712. Okay, so bringing my calculator back up. Step 1, break the equation into 2 parts. Well, I guess I shouldn't have done that yet. So my first equation is going to be 0.4 to the exponent x. My second equation is going to be 25. So those are the 2 equations I'm going to enter in. So I go to my equation editor. I put 0.4x in. I put the 25 in. Now I go to the window. I know that my y value's got to go up above 25, so I'm probably going to pick 30. The x values, I'm hoping that it's pretty close. If not, I'm going to have to go back and check those x values. So when I hit graph, there is the curve, the 0.4x, and there's the 25. So they don't even meet. So I have to go back to my x value. And the question is, where are they going to meet? When I look here, there's a large separation, and it's probably going to get bigger because the curve's going downward. Here, the curve's moving up very, very slowly, so I got to increase the positive x-axis. So I close my ink layer, I go to window, and I got to change this max, x max up quite a bit. And it may take a couple of tries, so I'll try 100 to see what will happen. There we go. So always go up by, multiples of 100, 1,000, and so on and so forth. It just makes life quicker for you. So next I hit second and trace. I want number 5. I want an intersection. So the first curve, you always hit yes, so enter. That's my second curve, hit enter. Hit enter one last time, tell it to go ahead and solve it, since that's what I want you to do. And it comes up with the solution. Here's the point of intersection. Here's your answer. 62.5 and 25. Oops. So Point of intersection, POI, is equal to, I think it was 62.5 and 25. Again, you'll notice that the y value is going to match here. It's going to match here. The answer we want is the first one. So therefore, x has to equal 62.5 to get this equation to work. All right. I might just do one more quick example. Do I have the time here? I do. I just want to show if it's an algebraic one. So number 3, let's look at what happens if it's 2 to the exponent x minus 4 equals, let's go with 15. Okay, so the equation you're going to have, y1 will equal 2 to the exponent x minus 4. The second one will just be 15. So I'll pull that calculator up quick here. And it's just, you got to be careful with the graphing calculator. And that's really all I really want to show here. So second 7, or plus 712, y equals 2. And this is where you got to be careful. That exponent has to be in brackets. Okay? It has to be in brackets for it to know that that whole thing's in the exponent. So it's just little quirks with the calculator. The window, I'm going to move my y-axis or y-max to a 20. See what happens. So there's the 2 to the exponent x minus 4, and there they cross. Okay. Now, when you go to calculate it, so trace, and then 5, there's my first curve, second curve. So I found the point of intersection. It's at 7.9. So therefore, point of intersection, 7.9 and 15. So therefore, okay, the x value is equal to 7.9. So what I want to point out is two things. Okay, first thing is you need to put brackets around the x minus 4. So that's the first point I want to make when you go to the calculator. Second of all, the calculator gives you final answer. You do not have to use the minus 4 again, because I always have some people thinking, oh, that's x minus 4 equals 7.9. No, the graphing calculator gives you x, gives you final answer. So the homework here on page 18 is just practicing with the calculator. That's what it is. It's really not teaching you a new skill. It's just getting you practice so that we can use the word problems or solve the word problems that are coming up next day. If you have any problems with that calculator, make sure you give me a shout and I will help you out as best I can.